In the previous lecture of basic electrical engineering, we are discussing till the types of phasors, in which we are studied rectangular, polar and trigonometric forms. In this lecture, we are discussing from the addition of phasors. So how addition of phasors takes place? So rectangular form is the most suitable form for the addition of phasors. रेक्टेंगुलर फॉर्म को सबसे सुटेबल माना जाता है एडिशन के लिए. रेक्टेंगुलर फॉर्म में एक होता है रियल और एक होता है इमेजिनरी कंपोनेंट, जिसे हम एक्स एक्सिस और वाई एक्सिस भी बोलते हैं. जैसे कि V1 बार के लिए A1 प्लस जे B1, वेयर B1 is a imaginary and A1 is real, which means A1 is along x axis and B1 along y axis. And similarly V2 bar A2 real and minus B2 is imaginary. So horizontal and vertical components are added separately. So A1 and A2 are added and B1 and B2 are added. After that the magnitude, हम मैग्नीट्यूड फाइंड कर सकते हैं जो होगा रूट ऑफ A1 प्लस A2 का स्क्वायर प्लस B1 माइनस B2 का स्क्वायर. ये माइनस साइन यहाँ इसलिए आ रहा है क्योंकि यहाँ पर मैग्नीट्यूड B2 का माइनस था. सो ऐड करने के बाद B1 माइनस B2 होगा. सो इट इज सिमिलर टू पाइथागोरस थ्योरम. दिस component is the horizontal component and this component is the vertical component, and the hypotenuse is given by this according to this, and angle we find with the help of tan function. Tan theta is equal to P upon B, which means perpendicular upon hypotenuse. Here the perpendicular component, which means by y-axis, is B1 minus B2 and x-axis is A1 plus A2. We obtain theta is equal to tan inverse of B1 minus B2 upon A1 plus A2. I hope you understand. After that, subtraction of phasors. So subtraction के लिए भी रेक्टेंगुलर फॉर्म को ही बहुत सुटेबल माना जाता है. सो V1 बार माइनस V2 बार, A1 माइनस A2 एंड B1 माइनस B2 इज इक्वल टू B1 प्लस B2. सेपरेटली अलग अलग हो गए ये दोनों. फिर से मैग्नीट्यूड होगा सिमिलरली रूट ऑफ A1 माइनस A2 का होल स्क्वायर प्लस B1 प्लस B2 का होल स्क्वायर, सिमिलरली टू एडिशन. एंड angle is equal to tan inverse B1 plus B2 vertical component upon horizontal component A1 minus A2. Then multiplication of phasors. For multiplication, polar form is the most preferred form. Polar form को most preferred form माना जाता है. So rule for multiplication of phasors: multiply their magnitude and add their angles. हम जानते हैं कि पोलर फॉर्म को इस तरह से लिखा जाता है, जैसे V1 बार के लिए V1 एंगल θ1 इंटू V2 बार के लिए V2 एंगल माइनस थीटा. लेट सपोज द एंगल इज माइनस थीटा. सो मल्टीप्लाई द मैग्नीट्यूड्स विच मीन्स V1 इंटू V2, हियर वी राइट, एंड एड द एंगल्स विच मीन्स Q1 प्लस माइनस Q2, विच मीन्स Q1 माइनस Q2, सॉरी θ1 माइनस θ2. ये क्यों जैसा लग रहा है, बनाया तो मैंने ही है. So after that, for the division of phasors, here is also polar form is the most preferred form, and rule: divide their magnitude and subtract their angles, which means V1 bar upon V2 bar is equal to V1 upon V2 and subtract their angles, which means Q1 minus Q2. So Q1 plus Q2. We obtain V1 upon V2 angle Q1 plus Q2. I hope you understand addition, subtraction, multiplication and division of phasors. एडिशन और सब्सट्रैक्शन के लिए रेक्टेंगुलर फॉर्म प्रेफर होता है और मल्टीप्लिकेशन और डिवीजन के लिए अपन पोलर फॉर्म को प्रेफर करते हैं. आफ्टर दैट AC circuit containing resistance only. So this is the rough diagram. तो हमें गिवन है कि जो वोल्टेज हमें मिल रहा है, जो साइनसोइडल जो AC वोल्टेज हमें मिल रहा है, V is equal to Vm sin omega t. We know that V is equal to IR by Ohm's law. IR is equal to where Vm is the peak voltage, so Im is the peak current, IMR. RR cancel, I is equal to Im sin omega t. We obtain the value of I. So the phase difference between I and V is 0 because here is sin omega t and also in voltage sin omega t. So phase difference between both is 0. हम इसी तरह से पावर भी निकाल सकते हैं. पावर होता है VI, V इंटू आई. हम जानते हैं कि V क्या है, Vm sin omega t और I क्या है, Im sin omega t. So these are peak values and constant. तो Im into Vm sin square omega t. We multiply both denominator and numerator by 2. You can see 2 sin square omega t by trigonometric identity. The trigonometric identity is cos 2 omega t is equal to 1 minus 2 sin square omega t. Again cos 2 omega t is equal to 1 minus 2 sin square omega t. We obtain 2 sin square omega t is equal to 1 minus cos 2 omega t. After that, average value of one complete cycle. So we obtain 1 minus cos 2 omega t. We multiply Im Vm by 2 with 1 and Im Vm by 2 with cos 2 omega t. So the average value of cos 2 omega t in a complete cycle is 0. So only Im Vm by 2 is obtained. So we split 2 into root 2 into root 2, root 2 into root 2, and Im by root 2 is equal to IRMS and Vm by root 2 is VRMS. So the phasor is like this. This is the phasor for current and this is the phasor for voltage. So you can see how the waveform of current is formed for a complete cycle and how the waveform of voltage is formed for the complete cycle. And the power is always positive. This is cancelled. After that, AC circuit containing inductor only. This is the rough diagram. Given again, V is equal to Vm sin omega t according to the law of electromagnetic induction given by Michael Faraday. E is equal to minus L di by dt, where L is self-inductance. Induced EMF is equal to applied voltage because the inductor store the energy and produce a EMF opposite to the direction of source. So this negative sign is showing the same thing. So we obtain E is replaced by V because V given V is equal to Vm sin omega t. So equal EMF, equal opposing EMF is generated in the inductor. Equal opposing EMF is generated in the inductor. V is equal to L di by dt. After that, we put the value of V. We obtain Vm sin omega t is equal to L di by dt, differentiating both sides. After shifting, we obtain di and differentiating both sides. Differentiation of di, I, Vm by L is constant. The differentiation of sin omega t is minus cos omega t by omega. Minus cos omega t by omega. We write cos omega t by corresponding complementary angle sine pi by 2 minus omega t, and after that multiplying this sign inside we obtain omega t minus pi by 2. After that, this is the peak current Im. This is the phasor for voltage and phasor for current, because the current is lagging by phase pi by 2. The voltage is V is equal to Vm sin omega t, but the current is I is equal to Im sin omega t minus pi by 2. After that, current is lagging behind by the phase difference pi by 2. We obtain the phasor for voltage corresponding to voltage. This is the phasor, and corresponding to current, this is the phasor, and we obtain power in that way. Between one alternation is negative and one alternation is positive, which means the average power in complete cycle is 0. So power is given by P is equal to Vm sin omega t into Im sin omega t minus pi by 2. Vm Im sin omega t cos omega t. This we can write cos omega t. After that, Im Vm by 2, multiplying both denominator and numerator by 2. So 2 sin omega t cos omega t is sin 2 omega t, and 2 is remained. After that, average power in one complete cycle. The average value of power in one complete cycle is 0, because the value of sin 2 omega t in complete cycle is 0. So after multiplying with 0, P is equal to 0. You can see one alternation is negative and one alternation is positive. After that, AC circuit containing capacitor only. This is the rough diagram. Given V is equal to Vm sin omega t, we know that C is equal to Q by V. We obtain Q is equal to CV. This differentiating both sides, dq by dt is equal to, C is a constant, it come outside, d Vm sin omega t by dt. Differentiation of sin omega t is cos omega t omega. Vm is also constant, so it also come out. Vm, V0 are both same thing. So dq by dt, we know that charge flow in unit time, which is current. So I is equal to C Vm omega t. C Vm omega sin omega t plus pi by 2. We can write cos omega t as the complementary form in sin omega t plus pi by 2, because in 90 degree we can change the function. After that, C Vm omega is the peak current for the capacitor, and we obtain the reactance for the capacitor. How this reactance is calculated? You can see C Vm omega is equal to peak current and Vm by Im is the resistance, and shifting this C omega. This is what we called XC, which means reactance due to capacitor. So this obtained. Power is also 0 because the phase difference between current and voltage is pi by 2. Power is 0. You can see the phases. Current is leading by phase pi by 2 because the sign is positive. Here we taking sin omega t plus pi by 2, and in the previous for inductor we are taking sin omega t minus pi by 2 because there is a negative sign outside. This is the cause for that. So this is the phasor for current and voltage. The average power for the capacitor is 0 for complete cycle. After that, RLC series circuit. So both the three circuit which we have studied previously, this is the combination of all three. We know that VR is equal to IR, VL is equal to IXL, and VC is equal to IXC. We find the reactance due to capacitor XC, and similarly we can find for the inductor, and we know about resistor. अगर किसी सर्किट में वोल्टेज ऑफ इंडक्टर ज्यादा होता है, द वैल्यू ऑफ VL इज ग्रेटर देन VC, देन it is called inductive circuit, and if the value of VL is less than VC, is called capacitive circuit. This is the point to remember. So this phasor can be created with the help of phase difference which we obtain in the individual circuits, that current is leading by voltage in the capacitor and current is lagging with the voltage in inductor. We obtain the resultant, this V, with the help of parallel shifting. This is VL minus VC, है ना. Here we obtain VL minus VC and shifting parallelly here, and we obtain with the help of triangle rule V. So V is the total opposition. So V, similarly by Pythagoras theorem, V is equal to root VR square plus VL minus VC का whole square. After that, here we are discussing about inductive circuit because the value of VL is greater than VC. So after that, VR is equal to IR square and VL is equal to IXL minus VC is equal to IXC whole square. The I is common in both these, so I is come out, and left is root R square plus XL minus XC whole square. After that, we know that V is equal to current into opposition. This is the value of voltage, current into opposition. So I into Z. We obtain Z is equal to root R square plus XL minus XC whole square. V is equal to IZ, II cancelled. The phase angle. तो फेस एंगल RLC के लिए हम निकाल सकते हैं tan phi से. Tan phi is equal to P upon again B, P upon B. So perpendicular is VL minus VC and base is VR. So VL minus VC upon VR. VL is equal to IXL and VC is equal to IXC and VR is equal to IR, है ना. II cancelled and we obtain VL minus VC upon R. Power is equal to VI cos phi. After that, power factor. Power factor is called cos phi. The value of cos phi is B upon H, which means VR upon V and R upon Z. After that, again points to remember. अगर XL ग्रेटर देन होता है XC से, तो करंट हमेशा लैग करेगा, जैसे कि हमने इस केस में देखा है. करंट हमेशा लैग होगा VL से. सो आई इज इक्वल टू आई एम साइन ओमेगा टी माइनस फाइव। और अगर एक्स एल लेस देन होगा एक्स सी से तो करंट हमेशा लीड करेगा। आई इज इक्वल टू आई एम साइन ओमेगा टी प्लस फाइव। और अगर एक्स एल इज इक्वल टू एक्स सी होगा तो सेम फेस में होंगे, तो आई भी सेम ही फेज में होगा वी के। आई इज इक्वल टू आई एम साइन ओमेगा टी। अब इम्पीडेंस ट्रायंगल क्या होता है, जैसे कि हमने अभी देख लिया था आर एक्स एल माइनस एक्स सी और जेड। वी ऑब्टेन दिस ट्रायंगल विद द हेल्प ऑफ दिस। So this is the impedance triangle. This triangle is showing when XL is greater than XC and when XL is less than XC, then this. Then the phasor become downside and we obtain Z as a resultant. After that, the concept of powers. How many types of powers? So powers in AC circuits. So हम powers में ये मान के चल रहे हैं कि करंट लेग्स बिहाइंड बाय फेज डिफरेंस फाई, करंट फेज डिफरेंस फाई से पीछे चल रहा है, जैसे कि हमने अभी देखा था RLC सर्किट्स में। सो एपरेंट पावर केवल डिनोट करने के लिए यूज होती है, ये कोई रियल पावर नहीं होती। इट इज द प्रोडक्ट ऑफ RMS वैल्यू ऑफ अप्लाइड वोल्टेज एंड करंट यूज्ड व्हेन पावर फैक्टर इज नॉट नोन। जो हमें पावर फैक्टर नहीं दिया होता, यानी कि फाई की वैल्यू नहीं होती, कॉस फाई हम नहीं निकाल पाते हैं, तब हम एपरेंट पावर का यूज करते हैं। इसे डिनोट किया जाता है एस से। एक्टिव पावर, दिस इज द रियल पावर। यही होती है अपनी रियल पावर जो टर्बाइंस को रोटेट करने के लिए आती है, जो टॉर्क प्रोड्यूस करने के लिए होती है। पावर विच इज एक्चुअली डिसिपेटेड, दैट इज इन RLC ओनली ड्यू टू रेजिस्टर पावर इज डिसिपेटेड। जैसे कि RLC सर्किट में पावर ड्यू टू ओनली रजिस्टर ही डिसिपेट हो रही है, क्योंकि जो इंडक्टर और कैपेसिटर है उनमें पूरी साइकिल, जो कंप्लीट साइकिल है उसमें पावर जीरो हो जाती है, एवरेज पावर जीरो हो जाती है। तो केवल रेजिस्टेंस के ही वजह से आती है, पावर डिसिपेट होती है RLC सर्किट में। तो P इज इक्वल टू वी आई कॉस फाई एंड V इज इक्वल टू आई आर, आई स्क्वायर आर कॉस फाई वॉट। कॉस फाई भी आएगा यहाँ पर। सो द थर्ड पावर इज रिएक्टिव पावर विच इज डिनोटेड बाय थीटा। पावर डेवलप्ड इन द रिएक्टेंस ऑफ सर्किट। जैसे कि इंडक्टर में एक अपोजिट EMF जनरेट होता है जिसके कारण एक रिएक्टिव पावर जनरेट हो जाती है, वैसे ही पावर डेवलप्ड इन द रिएक्टेंस ऑफ सर्किट। सो वी ऑब्टेन अ पावर ट्रायंगल। वी नो दैट after multiplying the resultant voltage into I, we obtain power. So we obtain its rectangular components Vi sin phi and Vi cos phi. Vi cos phi is the real power and Vi is the apparent power. We obtain power factor as active power upon apparent power. I hope you understand the all three powers. The active power is denoted by P, the apparent power is denoted by S, and the reactive power is denoted by theta. After that, we obtain active power is equal to P is equal to Vi cos phi. If P and V are constant, then only I and cos phi can be fluctuate. Then increase and decrease of current is due to power factor cos phi. अगर पावर फैक्टर इंक्रीज होता है तो करंट डिक्रीज हो जाएगा, बिकॉज PV इज कांस्टेंट, PYV इज कांस्टेंट। एंड अगर cos phi डिक्रीज होता है तो करंट इंक्रीज हो जाएगा। सो इसके डिसएडवांटेजेस हैं, जैसे कि ग्रेटर कंडक्टर साइज, बिकॉज इफ cos phi इज लेस देन करंट इज मोर एंड वी हैव टू greater conductor size, है ना, and due to this we have greater conductor size. Second, poor efficiency because of more resistance because of greater conductor size. Large kilowatt ampere rating because of a large conductor size and large current. Both are causing large kilowatt ampere rating. And one last topic is resonant frequency. Resonant frequency is that frequency where the current is maximum and the impedance is minimum. That causing when XL is equal to XC, the value of XL is equal to omega L and XC is equal to 1 by omega C. The value of omega is equal to 2 pi F. So we obtain F is equal to 1 upon 2 pi root LC. This is the resonant frequency not in use because it can damage the circuit, therefore avoid it. I hope you understand this lecture.